Somewhere in the sky tonight, a star is glowing that no longer exists. It burned out, collapsed, and vanished thousands of years ago, and the light announcing that death is still in transit, still years or centuries from arrival, so that anyone looking up sees only a ghost holding its old position, exactly as if nothing had happened at all. The Andromeda Galaxy, visible as a faint smudge on a clear night, is not being seen as it is. It is being seen as it was 2.5 million years ago, because that is how long its light has taken to cross the distance to Earth. 2.5 million years is not an abstract figure. It reaches back to a time before anything resembling a modern human had walked the planet. The image reaching a human eye tonight left its source when the earliest ancestors of the human genus were only beginning to appear. At the edge of the Milky Way, and at the center of countless other galaxies, sit objects that do something even stranger than delay light. They stop time. A person falling toward one of these, a black hole, would, by their own wristwatch, cross its boundary in an ordinary handful of seconds, noticing nothing unusual. But someone watching from a safe distance would never actually see that crossing happen. From outside, the fall appears to slow, then slow further, the falling figure dimming and freezing at the edge forever, according to the mathematics, without ever finishing the descent. Meanwhile, drifting through the empty space between star systems, are worlds with no sun at all, planets torn loose from whatever system built them, now wandering alone through permanent, absolute night. Current estimates suggest there may be more of these starless, sunless planets in the galaxy than there are stars. And on some of them, sealed under kilometers of ice and warmed only by heat leaking from their own core, there may be oceans of liquid water, and inside those oceans, quite possibly, something alive that has never once, in any generation, seen light. And beyond all of that, the universe itself is coming apart. Space is expanding, and that expansion is accelerating, stretching the distance between galaxies faster and faster until, eventually, distant galaxies will cross a threshold beyond which their light can never arrive here again, not because they moved away, but because the space between here and there grew too fast for anything to ever cross it. Billions of years from now, the night sky will be empty. A civilization arising after that point will have no way of knowing that other galaxies, or the Big Bang itself, ever existed. All the evidence will have physically vanished beyond reach. Every one of these facts is real, measured, and accepted by working physicists, not speculation, not science fiction. And together they describe a universe that operates by rules the human brain was never built to intuit, because that brain was shaped by 3 million years of judging the distance to a fruit tree and the speed of an approaching predator, not the behavior of light years, event horizons, or the accelerating expansion of space itself. What follows is an account of exactly how strange those rules actually are, and why, once fully understood, they turn out to reveal something worth far more than fear. Start with the most basic of them. Light takes time to travel. And that one small fact, followed all the way to its conclusion, quietly demolishes the very idea of now. Every signal that reaches an eye, a telescope, a photograph, every single one, has been traveling. Nothing in this universe is transmitted instantly. Light moves at a fixed, finite speed, fast beyond ordinary experience, but not infinite. And because it takes time to cross distance, everything ever seen is, by definition, old news. Not metaphorically old. Literally, physically, measurably old. Consider something close and familiar. Sunlight on skin, warm and immediate feeling. That light left the surface of the sun a little over 8 minutes before it landed on that skin. For those 8 minutes, an observer would have no way of knowing whether the sun had vanished, exploded, or simply flickered. The information hadn't arrived yet. Even the moon, hanging close by cosmic standards, is being seen roughly 1 1/3 seconds in the past. A phone camera captures light from over a second ago and calls it live. That gap is uncomfortable at planetary scale. It becomes vertiginous at galactic scale. The Andromeda Galaxy, the same smudge of light described a moment ago, is often called our galactic neighbor, the nearest large spiral galaxy to the Milky Way. It sits close enough, by cosmic standards, to be visible to the naked eye on a clear, dark night. But close, here, still means over 2 million years of travel time for its light, an era so distant that whoever first watched that light leave its source had no descendants yet capable of imagining a species that would one day build instruments to catch it. Every photon in that photograph began its journey before language existed, before fire was tamed, before anything that could be called civilization had so much as been imagined. The galaxy captured in that image is not a picture of Andromeda as it is. It is a portrait of Andromeda as it was, mailed across the cosmos 2.5 million years ago and only now arriving. Whatever Andromeda actually looks like at this present moment is unknowable. That information will not reach anyone on Earth for another 2.5 million years, at the earliest. And Andromeda is close. Reach further, out to the galaxies that deep-field telescopes photograph at the edge of visibility, and the light captured left its source not millions but billions of years ago, often before the Sun or the Earth had even formed. Look at those images, and what is being witnessed is not some far-off galaxy as it exists today. It may not even exist in that form anymore. It may have long since merged with a neighboring galaxy, or drifted into some entirely different shape, or, on longer timescales still, faded as its stars burned through their fuel. There is no way to know. The only available information is a photograph mailed across unimaginable distance, and by the time it arrives, it may already be a portrait of something that no longer exists. The most vivid version of this principle is written directly into the night sky in the form of stars. Every point of starlight is, quite literally, aged light, some of it aged by decades, some by centuries, some by many thousands of years. A star that appears, right now, as a steady, ordinary point of light might have already died. It might have already exhausted its fuel, collapsed, and in its final moments unleashed an explosion capable of outshining an entire galaxy, an event so catastrophic and so bright that, for a period of days or weeks, a single dying star can rival the combined light of 100 billion living ones. And the news of that death, encoded in light, is still traveling. It has not arrived yet. The star being admired tonight, glowing calmly in its fixed place, may already be a corpse, and the moment when that fact becomes visible is a message already in transit, decades or millennia into a journey with a fixed and unavoidable arrival time. There is a deeper layer to this, one that becomes more disturbing the longer it is examined. It is not only that distant objects are seen as they were in the past. It is that different objects, all visible within the same glance upward, are being seen from different pasts simultaneously, a scrambled, layered composite with no shared timestamp at all. The moon in that glance is a report from a little over a second ago. A neighboring planet might be a report from several minutes ago. A nearby star might be a report from years or decades ago. A more distant star might be a report from thousands of years ago. And a faint smear of a galaxy at the edge of visibility might be a report from millions or billions of years ago, all of it arriving together, in the same instant, onto the same retina, creating the powerful but entirely false impression of a single unified moment. The sky is not a photograph. It is a collage, stitched together from fragments of radically different eras, none of which actually coincide with one another, and none of which coincide with the moment of viewing. Push the thought experiment one step further, and something close to genuine vertigo sets in. Imagine, for a moment, a hypothetical observer with the power to freeze the flow of time and travel outward, instantly, to visit every star currently visible in the sky, arriving at each one simultaneously to see it as it actually exists at this exact moment. The picture that observer would find waiting would likely look nothing at all like what is currently seen from Earth. Some of those stars would already be gone, expired, collapsed, scattered into the surrounding gas, with their old light still crossing space toward a planet that, from their true present tense perspective, hasn't even received the news of their death yet. Others might have changed dramatically, brightened, dimmed, swollen into red giants, all invisible from here because the light carrying that information simply has not had time to arrive. The night sky, in other words, is not a display of the universe. It is an outdated advertisement for a universe that has already moved on, still playing to an audience unaware that the show ended long ago. There is no way to accelerate that message. There is no way to check the present tense of the universe. Every instrument ever built, every eye that has ever looked upward, can only ever receive delayed reports, a vast archive of history, layered across the sky, with the oldest chapters written into the faintest and most distant lights and the more recent ones closer to home. Looking up is not looking outward into space. It is looking backward into time, at thousands of overlapping moments from thousands of different pasts, all arriving simultaneously and being mistaken, by instinct, for a single shared present. This means, in the most literal and rigorous sense, that no living creature has ever seen the universe as it exists right now, and no living creature ever will. Right now, on a cosmic scale, is not a place that can be observed. It can only be inferred, calculated, and waited for, mail that has already been sent but has not yet arrived, sent from senders whose current condition remains, and will always remain, a mystery until their light completes its journey. The sky, then, is not a window. It is an archive, a gallery of ghosts, each one glowing with light emitted long before the observation, some of them glowing long after the source itself has already gone dark. Stargazing is not watching the universe. It is reading its old letters. And if that fact alone reshapes the sense of what a glance upward actually means, it is only the gentlest of the reality-breaking truths waiting in the depths of space. Because scattered throughout that same sky, hidden among the ordinary stars, are objects so extreme that they do not merely delay information, they devour it. They do not just distort the picture. They distort the picture-taking itself, warping the very fabric that time and space are made of. They are called black holes, and the name, though iconic, barely hints at what they actually are. The common image is of some kind of cosmic vacuum cleaner, an object that sucks in everything nearby with overwhelming strength. That picture, while emotionally satisfying, misses the deeper and stranger truth. A black hole is not simply a very strong source of gravity. It is a region where gravity has become so extreme that it has folded space and time in on themselves, carving a kind of one-way door into the geometry of the universe itself. Cross that door, and there is no path back, not because the exit is guarded, but because, past that threshold, every direction that could once be called outward no longer exists. Space itself has been rearranged so that all paths, including the paths that light itself would travel, lead only inward. Black holes are not rare theoretical curiosities confined to the pages of physics textbooks. They form through entirely ordinary, well-understood processes, playing out constantly across the galaxy. A star many times more massive than the Sun spends its life in a delicate standoff, the outward pressure generated by nuclear fusion in its core pushing against the relentless inward pull of its own gravity. For millions of years, that balance holds. But fusion cannot continue forever. Eventually, the star exhausts the fuel capable of sustaining that outward pressure, and gravity, which had been patiently waiting the entire time, wins. The star's core collapses in on itself, catastrophically, within a fraction of a second, crushing an object once larger than a star down to a point of unimaginable density. If the collapsing core is massive enough, nothing is left to stop that collapse. It does not merely become extremely dense. It continues collapsing, without limit, warping the space around it more and more severely, until it folds space itself into the shape of a one-way door. What remains is not debris, not a corpse in any conventional sense, but a permanent scar in the geometry of the universe, marking the spot where a star used to be. The boundary of that door has a name, the event horizon. It is not a solid surface, not a wall, not something that could be touched or scraped against. It is simply the last point from which light can still escape. One step closer, and even light, the fastest thing in existence, the very thing every other measurement in the universe is built around, cannot find its way back out. What happens near that boundary is where the truly disorienting part begins, because two observers, watching the exact same event, will witness two entirely different stories. Picture an astronaut approaching a black hole, falling steadily toward the event horizon, watched from a great distance by someone safe aboard a ship. From the astronaut's own point of view, nothing strange happens at the horizon at all. Time continues to feel completely ordinary. A wristwatch keeps ticking at its normal pace. The fall simply continues, smooth and uneventful, straight through the boundary and onward, a boundary invisible from the inside, with no local sign, no marker, nothing to announce that it has just been crossed. But from the perspective of the observer watching from a safe distance, the story reads entirely differently. As the astronaut approaches the horizon, gravity's grip on time grows stronger and stronger, and time, as measured from outside, appears to stretch and slow. The astronaut's fall looks like it takes longer and longer to complete. Each second aboard that falling body appears, to the outside observer, to take longer than the last. As the horizon draws near, the falling figure appears to slow almost to a stop, frozen at the edge, never quite seeming to finish the crossing, the image growing dimmer and dimmer, its light stretched to longer and longer wavelengths, fading toward invisibility, but never entirely vanishing, according to the mathematics of how the outside universe perceives it. The astronaut, from the outside view, becomes an eternal, fading photograph, forever approaching a threshold that, in their own experience, was crossed and passed within moments. Two accounts of the same event. Both are true. Neither is an illusion or a trick of the light. Time itself does not run at one universal rate. It runs according to the gravity being experienced, and near a black hole, that difference becomes not a subtle effect measurable only with atomic clocks, but a total divergence between two entirely different versions of the same story. And there is a further, stranger twist tucked inside the astronaut's own experience. Turning to look back the way they came, back toward the universe left behind, they would witness something extraordinary. The outside universe, from their falling frame of reference, would appear to run forward at accelerating speed. Stars would seem to burn through entire lifetimes in what felt like moments. Galaxies would seem to twist through eons of slow rotation and gradual evolution, compressed into what felt, from inside the fall, like the span of a single held breath. Falling toward the horizon means, in a very real sense, falling out of pace with time itself, watching the rest of the universe race ahead while personal experience continues to tick by at its normal, unhurried rate. And then, past the horizon, comes the point where description runs out entirely. At the very center of a black hole lies what is called a singularity, a place where, according to the mathematics that describe gravity everywhere else in the universe, density becomes infinite and the equations themselves stop producing meaningful answers. This is not simply a region of extreme conditions, comparable to the center of a star or the heart of an explosion. It is a place where the known laws of physics, the same laws that reliably describe the motion of planets, the burning of stars, and the falling of an apple, quietly stop applying altogether. Even the concept of time, so fundamental that its absence is difficult to even picture, is believed to lose its ordinary meaning inside that boundary. Some physicists describe crossing deep into a black hole not as traveling to a place, but as traveling to a moment from which there is no forward. A black hole, then, is not merely a strange kind of star. It is a hole torn in the reliability of reality itself, a location where the very rules the rest of the universe depends on quietly cease to hold, hidden behind a curtain of darkness so total that no signal, no light, no information of any kind can ever cross back out to describe what lies within. There is also a purely physical violence to the approach that deserves to be reckoned with, separate from the strangeness of time itself. Gravity does not pull evenly across an extended object. It pulls more strongly on whatever is closer to its source. Near an ordinary star or planet, that difference is negligible, far too small to notice. Near a black hole, especially a smaller one formed from the collapse of a single dying star, that difference becomes extreme within a very short distance. An astronaut falling feet first would find their feet pulled with dramatically more force than their head, stretching the body along its length while compressing it from the sides, a process physicists have only half-jokingly named spaghettification, a description that is, unfortunately, entirely literal in its implication. Long before reaching the horizon of such an object, the astronaut would already have been torn apart at the level of individual cells, then molecules, the material of a body stretched into a thin, glowing filament falling toward the point of no return. Curiously, this particular horror does not apply equally to every black hole. The very largest black holes, the supermassive giants that sit at the centers of galaxies, including the one anchoring the Milky Way, with masses reaching millions or even billions of times that of the Sun, have such enormous event horizons that the difference in gravitational pull between one end of a falling body and the other becomes comparatively gentle at the horizon itself. A hypothetical astronaut falling into one of these giants might cross the event horizon completely intact, feeling nothing unusual in the moment of crossing, unaware that the boundary had even been passed, the true violence of spaghettification only catching up much deeper inside, closer to the singularity. Scale, in this one strange respect, offers something almost like mercy, a horizon so vast that its threshold can be crossed without a scream. And this, perhaps, is the first true vertigo of deep space, not merely that the past is being watched instead of the present, but that somewhere out there, scattered across the galaxy in numbers likely reaching into the millions, sit doorways to a place where the rules governing everything else, motion, causality, the forward flow of time, simply stop. Yet as strange as black holes are, they are, in their way, rare and exceptional objects. Most of what fills the space between the stars is something quieter, colder, and in its own manner just as unsettling, because it turns out that most of the planets in the universe may not have a sun at all. The instinctive picture of a planet involves a star at the center of things, warmth, daylight, a source of energy and rhythm. Every planet familiar in ordinary imagination, every planet in the solar system, orbits such a star. But that picture, comfortable and intuitive as it is, may not represent how most planets in the universe actually exist. A growing body of evidence suggests that the galaxy is filled with wandering worlds that have no star at all, planets cast loose from whatever system originally formed them, drifting alone through the vast darkness between stars. These are called rogue planets, and by some estimates, their numbers may rival or even exceed the number of stars in the galaxy itself. The process that creates them is a natural, almost inevitable consequence of how planetary systems form. Young star systems are chaotic places. Multiple planets, and sometimes multiple stars, jostle for stable orbits amid the gravitational influence of everything else nearby. In that chaos, close gravitational encounters between forming planets, or between a planet and a passing star, can fling a world entirely out of its system, accelerating it past the point where its home star's gravity can ever pull it back. Once released, that planet does not slow down and does not turn back. It simply continues onward, indefinitely, carrying the momentum of that final gravitational shove into the emptiness between the stars, with nothing ahead to stop it and nothing behind to reclaim it. What follows is a kind of solitude that has no real equivalent on any inhabited world. A rogue planet drifts through interstellar space in absolute and unbroken darkness. There is no day. There is no night, either, in any meaningful sense, because night implies a day that came before it and a sunrise that will eventually follow. And for a rogue planet, neither of those things exists at all, not once, not ever again. The nearest star might be so distant that its light, arriving after years or centuries of travel, contributes no more than a faceful of stars might contribute to someone standing at the bottom of a windowless room. Temperatures on the surface of such a world would settle close to the natural background chill of space itself, hundreds of degrees below anything survivable, a stillness and cold that make the coldest recorded places on Earth seem, by comparison, gentle and mild. And yet, this is where the story turns from bleak towards something closer to wonder. Total solitude and total darkness do not necessarily mean total lifelessness. Planets and larger moons generate their own internal heat, independent of any star, through a combination of leftover formation energy and the slow decay of radioactive elements buried deep within their cores. On a rogue planet large enough to hold onto a thick enough insulating layer, a shell of ice, kilometers deep, wrapped entirely around the planet like an insulating blanket, that internal heat has nowhere to escape to. Trapped beneath such a shell, it is conceivable that liquid water could exist, not a frozen surface, but a genuine ocean, kept in liquid form purely by pressure and internal warmth, sealed away from the killing cold above by kilometers of solid ice acting as an impossibly effective insulator. There is something worth pausing on in the sheer scale of this population. Estimates drawn from gravitational microlensing surveys, a technique capable of detecting the faint, momentary bending of distant starlight caused by an unseen object passing in front of it, even an object emitting no light of its own, suggest that rogue planets may outnumber the stars of the galaxy several times over. If those estimates hold, then the majority of planet-sized objects drifting through the Milky Way are not orbiting anything at all. They are simply out there, uncounted and largely undetectable by any conventional method, vastly more numerous than the comfortable, sun-orbiting worlds that dominate the popular imagination of what a planet even is. The picture of a planet as something warmed by a nearby star may, in fact, describe the minority case rather than the rule. Imagine, for a moment, what such a journey would actually involve, stretched across time rather than treated as an abstract fact. A rogue planet ejected from its birth system in its early history does not simply drift for a few centuries before finding some new equilibrium. It continues on that trajectory for the remainder of the galaxy's existence, potentially for many billions of years, crossing distances between stars that make interplanetary distances look trivial by comparison. Distances so vast that even light, moving at its fixed and enormous speed, requires years to cross the gap between one star system and its nearest neighbor. A rogue planet drifting through that gap experiences something close to true isolation. No gravitational anchor, no orbit, no rhythm of any kind, simply continuous motion through absolute emptiness, on a scale of time long enough to have begun before the sun existed and to continue long after the sun has died. This is not idle speculation detached from precedent. Similar oceans, thought to exist beneath the icy shells of certain moons within the solar system, are considered among the most promising locations in the search for life beyond Earth, precisely because they demonstrate that liquid water, and the chemistry that might arise within it, does not require sunlight to exist. It requires only warmth, and warmth can come from within a world just as easily as it can arrive from a star. Which raises an idea difficult to fully absorb. Somewhere out in the endless dark between the stars, sealed beneath kilometers of ice on a planet with no sun, illuminated by nothing at all, not starlight, not any light whatsoever, forever, there may exist an ocean. And within that ocean, warmed only by the planet's own internal engine, there is a real possibility that something could be alive. Something that has never known light in any form, whose entire existence, across every generation stretching back to its earliest ancestors, has unfolded in total and permanent darkness. A form of life for which the very concept of a sun, the concept so fundamental to every framework by which life on Earth is understood, would have no meaning whatsoever. Not myth, not memory, not even the faintest ancestral echo of daylight. Just an ocean, warmth from below, endless black above, and, conceivably, life quietly persisting inside it regardless. If such life exists, it represents something the human mind struggles to hold. existence entirely divorced from starlight, proof that the requirements assumed necessary for life may be far narrower than what life itself actually needs. The universe, it turns out, may not need a sun at all to build something capable of living. These wandering, sunless worlds are strange enough on their own, but they are also, in a sense, a preview, a small-scale rehearsal for a darkness that, according to current understanding of the universe, is coming for everything, eventually, on a scale far larger than any single planet. Because the universe is not simply large. It is actively getting larger, and it is doing so at an accelerating rate, and buried inside that single fact is one of the strangest and most quietly unsettling discoveries in the history of science. This particular story begins with one of the more disorienting realizations in the history of astronomy. For most of human history, the universe itself was assumed to be static, fixed, unchanging, eternal in its basic layout, with stars simply occupying their places against a permanent backdrop. That assumption held even among leading physicists well into the 20th century, so strongly that early equations describing gravity across the cosmos were deliberately adjusted with an extra term specifically designed to force the mathematics to describe a static, unmoving universe, because the idea of an expanding or contracting cosmos seemed, at the time, obviously implausible. That adjustment would later be described by its own author as one of his greatest errors, because it was wrong not for being too bold, but for not being bold enough. For much of the 20th century, astronomers understood that the universe was expanding, a discovery traced to the observation that distant galaxies appear to be receding, their light stretched toward longer wavelengths in a way that scales with distance. The expectation, reasonable and intuitive, was that this expansion should be gradually slowing down over time, the same way a ball thrown upward slows as gravity pulls back against it. Every object in the universe exerts gravitational pull on every other object, and that pull should, over time, act as a brake on cosmic expansion. Instead, observations in the late 1990s revealed the opposite. The expansion of the universe is not slowing down. It is speeding up. Something is pushing space apart, and that push is intensifying as time goes on. Whatever is responsible for this has been given a name, dark energy, but the name is, in an important sense, a placeholder for something not yet fully understood, an unexplained property of empty space itself, one that appears to make emptiness push outward on itself, and one that appears to be winning, decisively, against the combined gravitational pull of every galaxy, every star, and every black hole in existence. The consequence of that discovery unfolds slowly across cosmic time, but its endpoint, if current understanding holds, is almost unbearably lonely. As space itself continues to stretch, the distance between galaxies that are not gravitationally bound to one another grows larger and larger. Beyond a certain distance, that stretching adds up to something remarkable. Those galaxies begin to recede at a rate faster than light itself can cross the growing gap between here and there. This does not violate any law of physics. Light is not being outrun through space. Space itself is simply expanding faster than light can cross it, but the practical result is the same as if it had been outrun. Once a galaxy crosses that threshold, its light can never arrive. It becomes permanently, irrecoverably unreachable, not because it has moved away in any conventional sense, but because the space between here and there has grown too fast for anything, ever, to cross it again. Galaxy by galaxy, over spans of time measured in billions of years, this process continues. The visible universe slowly, gradually, empties out. Not because galaxies are being destroyed, but because they are drifting beyond a horizon that nothing can ever cross back over. Trillions of years from now, if current models hold, nearly every galaxy beyond a small, gravitationally bound local cluster will have receded past that horizon entirely. What this means for anyone or anything looking upward from within that remaining cluster, in that unimaginably distant future, is almost impossible to sit with comfortably. The night sky, for any civilization arising after that point, would show only the stars of its own galaxy, its own tightly bound cluster, if a merger with a nearby galaxy has occurred, and nothing more. No other galaxies. No expanding universe visible on any instrument, no matter how sensitive. No fading, ancient light left over from the early universe's formation. Every trace, every piece of physical evidence pointing toward the existence of billions of other galaxies, an expanding cosmos, and an unimaginably distant origin point in time, will have already receded beyond any possibility of detection. Even within that remaining local cluster, the long-term picture is not one of permanence. Current models suggest that the Milky Way and its largest nearby neighbor, the Andromeda Galaxy, the same galaxy whose ancient light was described earlier, are gravitationally bound closely enough to eventually merge, drawn together over billions of years into a single larger galaxy, sometimes described informally as a future merge system. That merger will scramble stellar orbits, trigger new bursts of star formation, and eventually settle into a new, more massive galactic structure. It is this merged remnant, and whatever small number of smaller companion galaxies remain gravitationally bound tightly enough to resist the overall expansion, that will constitute the entire visible universe for any civilization arising in that distant future. An island, alone, surrounded by nothing detectable in any direction, forever. A civilization born into that era, however intelligent, however advanced its instruments, would have every reason to conclude that its own galaxy was the entirety of existence. They would build their physics, their philosophy, and their entire understanding of reality around the observable fact of a single, isolated island of stars, surrounded by nothing at all, and they would have no way of knowing that they were wrong. Not because of any flaw in their methods or their reasoning, but because the evidence required to know otherwise would have physically vanished, carried beyond reach by the very fabric of space itself, long before their civilization ever began to ask questions. This detail carries a very specific and sobering implication. Right now, in this era, evidence of the universe's true scale and origin is still visible. The current age of the universe happens to fall within a narrow cosmic window during which the leftover glow of its earliest moments and the light from countless distant galaxies remain observable, has not yet fully receded beyond reach. Telescopes today can still detect this evidence, still reconstruct the story of a single, unimaginably hot and dense beginning, expanding outward for over 13 billion years into the vast structure of galaxies now visible. That evidence will not be available forever. It is not guaranteed to any future observer. It happens to be available now to whoever occupies this particular sliver of cosmic time, and there is something worth sitting with in the knowledge that later observers, however capable, will not have access to the same view. And that, in the end, is where all of these strange and destabilizing facts quietly converge, not into despair, but into something closer to gratitude and something closer to awe. Faced with all of this, light delayed across unimaginable distances so that no one ever truly sees the present, boundaries in space where time itself stops flowing for anyone watching from outside, countless sunless worlds drifting alone through permanent darkness, some of them perhaps quietly sheltering life that has never known daylight, and a universe tearing itself apart at an accelerating pace, erasing its own evidence galaxy by galaxy as it goes. It becomes very easy to feel small. Not small in the gentle, humbling sense often invoked when looking at a beautiful night sky, but small in a colder, more literal sense, a brief flicker of organized matter, clinging to a modest rock, orbiting an unremarkable star, in an ordinary galaxy, in a universe that shows no evidence of caring whether that flicker continues or fades. And yet within that smallness sits something extraordinary, something that deserves to be stated plainly rather than dismissed as a comforting platitude. The atoms that make up a human body were not created on Earth. Every atom of carbon, every atom of oxygen, every atom of iron in blood, was forged inside the cores of stars that lived and died long before the sun ever formed, stars that spent millions or billions of years fusing lighter elements into heavier ones, and then, in their final moments, scattered those elements outward in violent deaths, seeding the cloud of gas and dust that would eventually collapse to form the solar system. Every person walking the Earth is, quite literally and without exaggeration, made of material forged in the furnace of long-dead stars. The same violent, indifferent universe capable of black holes that erase information and an accelerating expansion that will one day erase entire galaxies from view is also the universe that built the raw material for thought, for curiosity, for the capacity to look upward and wonder what any of it means. Somewhere along the way, undirected physical processes, stars burning, exploding, scattering their contents across the galaxy, gravity slowly collecting that scattered material into new stars and planets, produced, on at least one small world, a species capable of building instruments that catch ancient light, translate it into images and numbers, and use it to reconstruct the history and structure of the very universe that made it possible in the first place. Matter looking back at the processes that assembled it. Atoms, organized into a mind, using that mind to understand the furnace they were forged in. There is no known law of physics that required this to happen. Nothing in the equations governing gravity, or fusion, or the behavior of expanding gas clouds, demands that any of it eventually produce curiosity. A universe entirely without observers is, as far as the underlying physics is concerned, just as consistent and just as complete as one that happens to contain them. Stars would still burn. Black holes would still warp spacetime. Galaxies would still drift apart under the pressure of dark energy. All of it would proceed exactly as it does now, mechanically, indifferently, whether or not anything anywhere was capable of noticing. The fact that something did notice, that somewhere, on one modest planet, orbiting one unremarkable star, matter arranged itself precisely enough to begin asking why any of this was happening at all is not a requirement of the system. It is closer to a strange and fragile accident, layered on top of physical law rather than demanded by it. And it is fragile, in a very literal sense. The conditions that allowed this particular flicker of understanding to arise were narrow and specific: a star stable enough to burn steadily for billions of years without violent variation, a planet positioned at precisely the right distance to allow liquid water to persist on its surface, a molten core generating a magnetic field strong enough to deflect the more destructive forms of radiation streaming outward from that star, plate tectonics recycling carbon in a way that kept the atmosphere within a survivable range across geological ages, a large moon stabilizing the planet's axial tilt against chaotic drift, and an uninterrupted multi-billion-year stretch of time during which no catastrophic impact, no nearby supernova, no sustained instability wiped the slate clean before evolution had the chance to build something capable of eventually asking questions about any of it. Remove almost any one of those conditions, and the story likely never reaches the point of a mind capable of building a telescope, let alone one capable of turning that telescope toward the sky and beginning to understand what it was looking at. The universe itself does not seem to care whether this happens or not. It offers no built-in purpose, no guarantee of meaning, no promise that any of its structures, planets, stars, galaxies, or the beings occasionally arising on some of those planets, will last, or matter, or be remembered. Its future, on the longest timescales, points toward isolation and cold, galaxies drifting apart until nothing remains visible but a lonely, darkening sky. But for this specific moment, in this specific and narrow window of cosmic time, that indifferent, mostly empty, physically extreme universe has produced something capable of looking at itself and beginning, however imperfectly, to understand what it is looking at. A universe that runs on rules stranger than any story, viewed by minds built from its own former stars, curious enough to ask what those rules mean, brave enough to sit with answers that unsettle every inherited intuition, and lucky enough to be alive during the one narrow era when the evidence of its own vast and impossible history is still there to be found. There is a way of holding all of this that leads only to despair, the interpretation that, because the universe is vast, cold, and indifferent, nothing that happens within it can possibly matter. But there is another way of holding it, equally justified by the same facts, that arrives at something closer to the opposite conclusion. If meaning and understanding are rare enough that they may exist nowhere else in the visible universe, or in only a handful of scattered places across billions of galaxies, then their presence here becomes not less significant for being small, but more significant for being improbable. A universe overflowing with minds capable of understanding it would make any single mind almost unremarkable. A universe that produced, at most, a scattering of such minds across its entire vast structure makes each one something closer to miraculous, not in a supernatural sense, but in the ordinary sense of an outcome so unlikely, so dependent on an unbroken chain of precise conditions, that its occurrence deserves to be treated as remarkable rather than routine. Every fact explored here, the delay built into every active scene, the horizon beyond which time itself stops mattering, the sunless worlds drifting in permanent night, the runaway expansion slowly erasing the evidence of the universe's own past, describes a cosmos with no apparent interest in being understood, no design oriented toward producing understanding, and no guarantee that understanding, once it arises, will persist for any meaningful length of time. And against that entire backdrop, for one brief interval, on one small and unremarkable planet, it happened anyway. Not because the universe wanted it to, simply because, given enough time, enough raw material, and enough chance, it was possible, and possible, eventually, became actual. That is the story hiding behind the calm, quiet sky. Not a peaceful dome at all, but a message written in ancient light, arriving from a universe that never intended to be understood, and yet, against every reasonable expectation, briefly is.